Good morning, students. So, today I have planned to take one lecture on turbines. So, turbine is very important for any industries because it's provide a method or support to drive the machine. The basic what is the purpose of turbine is purpose is to drive compressor or any pump. So the thing is that turbines are efficient and reliable because power is also another source, but reliability of the power grids is relatively less in comparison to the steam because power plants and we have a backup and steam requirement of a turbine will be comparatively less. So from that angle it is normally good to have turbine, but normally for more reliability purpose we are keeping both the option that the critical machines are normally turbine driven as well as motor driven both. So turbine is as I told you, it is steam turbine. So turbines depending upon the requirement, types of turbines are different. One is let down turbine. Let down, as the word itself told, let down. That means we are letting down. That means we are reducing the pressure. So normally in our industries we are having three level of steam pressures. We are calling high pressure, medium pressure, low pressure, or we are calling SH, SM, SL. SH, SM, SL means high, medium, low, or steam. So that way, and pressure normally from ammonia plant or methanol plant, normally the pressure for SH is in the range of 110 bar, and for SM it is around 30 to 35 bar, and SL will be 3 to 4 bar. So let down turbine, that means if I have a let down turbine where my inlet steam is SH, then it can be SH to SM, or it can be SH to SM, and then it can be SM to SL. So depends upon the requirement, power requirement, and the machine which is hooked with this turbine will decide what type of turbine I am going to decide. Most efficient turbine is condensing turbine, but the thing is that if I am going to have a big requirement, then the condenser volume and size will be very huge. So what we are doing, we are going one stage with let down, that is from SH to SM, and then last stage we are going for the condensing. So normally suppose we are having a turbine where SH is in the range of 250 to 350, then what we are doing, we are going for the condensing between 80 to 100. So if suppose 100 is the condensing, then we are taking extraction at 30 bar, and then this 30 bar is going to the header which is joining to the SM header. So it meets the requirement of the SM for the system, because in reforming we need medium pressure steam. So normally the steam network is decided into three level: SH, SM, SL, and there is a provision also to put this extraction on auto. So depending upon the SM requirement, we can manipulate the automatically. If systems are not robust and then we can keep this on manual also. So what is the system is that SH steam, it may be meeting by having a high pressure boiler, or in ammonia plant we are having, or methanol plant we are having reform gas boiler. So once we are having reforming gas coming, then that heat recovery generates the high pressure steam, which is getting saturated steam, and then it is passed through the convection coil and then superheater, where burners are there to maintain the superheater steam temperature in the range of 300 sorry 505. Saturated at 110 is in the range of around roughly 320. From 320 to 510, that means around 180 to 190 degrees superheat we are doing. This is actually to avoid any condensation and to get the heating value requirement. So this is SH header. SH header we are having going to the turbines and having one letdown station also, which control the SH header as well as the SM header requirement. Normally SM header, all SH to SM letdown is coming, and we are hooking the package boilers as per the requirement. So some plants are having 2 package boilers, some are having 3, or in the ammonia fertilizer plant what I am seeing is this package boilers and SH steam requirement, these are part of the utilities. And in methanol plant is actually combined, the utilities as well as process, everything is in the one premises. So same person, shift in charge or senior production supervisor, who is in charge taking care of all. So if you see in fertilizer industries, like ammonia plant is separate, utilities are separate, and urea plant is separate. But in that in power plant means people are taking care for the water, their treatment, and DM water generation and BFW water generation. In urea plant they are taking care for the formation of urea and then prilling, and then next is the bagging, where this prilling urea is going through belt to the silo as well as to the packaging unit. In ammonia plant basically it's only instrument air system, nitrogen system, and in latest plant argon also associated, and PGR is there, and then ammonia reforming section is there, compressor section is there, and then we have a synthesis section, and then we have a refrigeration and ammonia withdrawal system is there. But in methanol plants what I have seen, like we have a desalination plant, if because we are close to sea, then we are taking the water from the sea. In India, if you are close to river, then you are taking the water from the river. So accordingly the process has been designed. So desal water, we are with the help of steam we are generating the water requirement, meeting the water requirement. Then we have a polisher to convert this water into polished water, and then we have a separate instrument air system, plant air system, nitrogen plant, and then also we have a wastewater plant. So wastewater plant also depends upon the type of industries. It may be bacteria related system, or it can be microbiological system, or some other methods are also there. So depending upon the requirement, cost optimization, availability of the equipment. And then in methanol plant we are having a distillation, compressor, reformer, and then methanol section, tank farm area, and then finally shipping, and so that comes under jetty. So sometime it is part of the particular industry itself, or sometime a common jetty system is there, where all the companies is having a common network through which it is loaded to the ship. For that proper nomination, information, shipping, surveyor is actually a type of a person, third party, which coordinates between the oil tanking, or what I can say jetty persons, and the respective plants. So because this product which we are sending through ship has to be quality certified first at the site itself, and when it will be offloaded again it will be certified, so that there should not be any issue with the customer satisfaction. It is we are doing this to cross check the quality in between any contamination while transportation or while shipping or while pumping. So various samples at various destination or key points are there, and that we are taking and kept as a record till final offloading took place at the destination. Now coming back to the turbine, the purpose of turbine is to drive compressor. So various turbine manufacturers are available in the market. Few names are Mant, then BHL, Siemens. So turbines are normally split into two types. It can be vertically split or it can be horizontally. Means one portion this and another portion this, and then there are the casing bolts. So casing type horizontally split is common, but it may vary from industry to industry. Model is an identification. So like for any pump, we can say pump P 301, 302, but with the different terminology, UK terminology, then Indian terminology. So somewhere we are calling pump as a GA also. So it is not matter much. It's just a nomination method. We are taking name, like some person's name are Astosh, some person names are Ram, some person's name are Rajkumar. So how we communicate this so that all people in the company should know if what I am referring, and so that there should not be any confusion. So if it is two pumps are there, then it will be A and B. If it is single pump, then A and B will not be there. So accordingly, as per the requirement, it is there. Then driven type. Driven type, normally I am going to discuss more about the centrifugal, but compressor can be centrifugal, reciprocating, screw type. So variety of compressors are available. Reciprocating compressors are normally required if we want to go for very high pressure. And with reciprocating, efficiency is one issue, and maintenance also another issue. Centrifugal compressors are normally robust, and efficiency is also good with the centrifugal compressors. Characteristics, suppose when I want to define any turbine or something, so like pump also, so first thing is how much flow rate. So flow rate for the turbine, when I am talking, then I am referring to the steam required to run the turbine, or steam required at the rated speed. But when I am referring to the pump, then I am referring to the pump discharge flow. And this discharge flow, sometimes vendors are giving discharge flow cumulative, or sometimes they are giving discharge flow plus minimum recycle flow for the safety, which is going through the ARV. So capacity, if you are referring, you have to be careful कि what you will have the flow at the final destination will depend upon whether cumulative flow has been given or cumulative plus recycle flow is given. If suppose cumulative flow is given and recycle flow is mentioned separately, then finally you will get cumulative minus recycle flow. Because ARV will keep open, and but normally there is automatic recycle valves in the system, and once requirement is going more, then this automatic recycle goes in closed condition also, but there is that some minimum flow will always be there, so that you will not get in the final requirement. Another thing is flow, and second is pressure. So pressure, you will see in the data sheet what is the normal operating pressure. So if it is high pressure, then it will be 110 bar. If it is medium pressure, then it will be 30 to 35 bar depending upon the industry, and if it is low pressure, then it will be 3 to 4 bar depending. So similarly this will be there, then accordingly the temperature will be there, operating temperature. So as per the pressure, there will be a saturation temperature, but for turbines we are having superheated steam to avoid any condensation. So normally the superheated will be in the range of 100 to 180. So normally minimum 150 superheat for high pressure, accordingly for medium pressure 100 degree. So it is vendor specific, and the designers are taking care that there should not be any condensation. So although they are providing the traps and other thing, but with insulation also, condensation cannot be avoided. And while letting down through the turbine also, what is happening, it is not one stage turbine as such. 110 is coming, then it will go to next stage blades, then pressure will come down. So if it is such entering as that saturated steam or only very less degree of superheat, then that problem will that ki when it is getting let down, then internal condensation will be there. And when you have a two phase, one is steam and one is water, then this water will act like a pellet, and it will damage the blades and vibration of the machine. And so because of that, we need to assure at no stage inside the internal blades any condension will take place. So for that, last blade protection or some other blade protection non latest technologies are there. Okay, they are having a monitoring systems, and trips are linked with that blade protections. And then comes the design pressure and temperature. So for the inlet also, for intermediate also, and for the exhaust side also. Exhaust side, we are normally going to the vacuum. That is only to have the maximum efficiency. So that system is called a condenser, where we are going to maintain a vacuum of minus 0.85 bar. So for the safety point of view, normally at low vacuum also there is a trip is given. Now coming to the turbine speed is also mentioned as a minimum speed, maximum speed, and normal speed. And rotation from coupling, that means ki turbine can be rotate clockwise also, so and can be rotate anti-clockwise also. This rotation will decide how the labyrinths and blades are kept on the shaft. So if you want to rotate reverse, or because of some process upset, if turbine will go reverse, then this will get damaged, because it cannot have the you cannot place the diaphragm, blades, labyrinth in such a way that in both direction it is safe to run, because the clearances between the diaphragm and other things are very small, and it is only suited for the rotor to rotate along with the blade in a particular directions only. Governor type to control the speed of the turbine. Old type was PGPL governors, now electronic governors are also coming. And earlier this governor initial we are doing from the field, but now with all the plants you can do the startup automatically from the control room. And there are the provisions that earlier we are going to heat the system, so still we are going to field to ensure all the systems are line up and safe there. That means suctions are open, discharge are open, stream traps are in line, lines are condensates are drain out, there is no accumulation of water or anything in the systems. So after first initial checkup, you can do the complete startup. I can say 90% of the startups you can do now from the control room. Otherwise earlier when we are doing this turbine heating other, so because SH steam at very high pressure and temperature, so even going through the silencer it is making too much sound. And once you will see ki, steam is going inside the turbine, and there is a sudden drop in its atmosphere sound and other things, a person will know that now turbine has been rolled and it is going to the next stage like MGS and then final operating speed. Speed control range, speed control type may be 3 to 15 psi, or that is all instrument and mechanical requirements are there. So with the time, initially it was pneumatic, then it become electronic. So it's a other part of the discussion, but just for a feel I have said in between. And range of the speed control can be 80 to 105 of the rated speed means the maximum operating speed. Overspeed trip is normally given at the 110 of the rated speed, and this is basically a protection. And now automated overspeed protections are provided with the turbine, and to have the more reliability and safety, normally this are 2 by 3, 2 out of 3 means if 2 of the speed probes will sense that turbine has gone to overspeed, it will trip the machine. And with the that command, the XV which is at the inlet of the steam will go complete close, so that there should not be any steam introduction into the turbine. And there is also now the thing is that if it is linked with the some process side, so at that end also that XV should be closed and an RV should be available there, so that to avoid any back rotation if either of the XV fails to close. Critical speed of the machine is that where the speed becomes synchronized with the operating speed, then the vibration levels and other things are going high. So this is as per the API 612, and other latest APIs are also in there. So for that now one has to go with the latest, and this critical speed testing during shutdown is must to ensure the healthiness whether this system is operating or not. So now there are overspeed trip can be mechanical also, and it can be electronic also, and there is a relation which one we hire. So accordingly vendors are providing this is the RPM, this is the maximum operating RPM, and this is the mechanical overspeed trip, and this is electronic. So one has to refer this and has to test without fail in each shutdown. Some companies are having shutdown for 3 years, after 3 years, and some companies are having shutdown after 4 years. That's all depend upon the economics as well as the process condition, performance of the catalyst. So it's basically a complete planning. It is required lot of discussion if I will go into that. Next is the steam nozzle. So steam nozzle basically after the XPs for big machines, this nozzles are maybe 4 5 depending upon the capacity or megawattage. If it is 30 to 40 megawatt, so normally 4 numbers of nozzles are there, and these nozzles as per the requirement getting open. So with lower requirement 1 or 2 nozzle will come in action. Once you will go ahead, third nozzle will come in action, and when you are at the maximum speed, then 4. So this like if 1 2 3 4 nozzles are there, so when in slow speed, then first and last nozzle will get open. Like that its balancing is there, so that turbine should not face any upset or vibration level. So this tuning was done by the machine supplier, and they take place, and these nozzles are not normal block. It is having a shape, you can say ball with a variable diameter. So this once this walls is lifted, then steam flow to the chamber will be controlled by this nozzle. So this all decide how much steam I want to put inside. Accordingly the wall will lift, and then as per the speed number of walls will come into the actions. Then stages are there. So for each turbine, first is the impulse stage, and afterward depending upon the size of the turbine, reaction stages are there. It can be from 1 to M. M means it can be 10, it can be 6. So it depends upon the capacity. Exhaust condition also for good turbine, exhaust blade protection at temperatures, this is given, and there is normally a provision to control the temperature by adding quench, and it is going to the vacuum side to the condenser. So vacuum system also has to be maintained. The only thing is that the vacuum system there should not be any leak, because if vacuum get deteriorate, then it will come to the atmospheric pressure, and at that the efficiency of turbine will get affected. Shaft sealing, that is basically to avoid any leakage or something. We are using the labyrinth. Labyrinth is basically like a you can say a gear teeth, and there is a spacing, so that if oil is one side and process gas is another side, so it should not get mixed 100%. We cannot avoid mixing, but mixing will be very less. So earlier the system was having a, for this oil lubrication and leveling seal was there, so oil system was there. But nowadays sealing system that is called dry gas seal. So where we are using the buffer gas as well as nitrogen, and the life of the this system is good. Only thing that the buffer gas and nitrogen should be clean, and it should not have any condensate. So as long as you are able to maintain the quality of the gas which is going into the seals, dry gas seals are very efficient and effective, and it provides a good life. And now we are providing some tip logics also, ki if primary seals fails or secondary seals fails, how it will take care of the hazardous condition and at what condition machine will trip, or you have to decide as a operator or engineer to stop the machine from safety prospect, because if seal will damage, this all the synthesis gas will come into at high pressure into the atmosphere, and it will spread like anything, and valve formation as well explosion cannot be ruled out. Coming to the bearings, so radial bearing and thrust bearing. So thrust bearing are normally tilting pads, and now modified sinks are there. So all the bearing temperatures and vibrations, that system will you can see online on the DCS. That DCS means distributed control system, where people are monitoring, and monitoring is one thing, but now the systems are all automatic. Alarms are given to for the operator to take care. If it is not in control, then automatically trip system will take care of on its own. Then coming to the material of construction, casing can be any alloy or something. Stationary part is there, rotating part is there, seal is there. So quality, cost, reliability, so accordingly the chrome percentage can vary from 11 to 15 or 16, and then the seal can be SS, but if you want more robots, you can go for SS304. Type of fluid which you are handling, then it can be SS316L also. So this is the one thing. Now coming to the turbine startup. So turbine startup, so normally vendor provides the startup curve, and where one axis speed will be there and another axis time will be there. And how it is decided, ki it will be in steps. So once turbine is ready, it is heated up, casings and everything, and steam side is also heated up. Then vendor is nowadays providing automatic steps, okay, that from initial 0 to 1500 or something it will go, and then it will go in 10 minutes and it will sustain for another 10 minutes like that. Then it will go to next stage, 3000 rpm something, so depend upon the rpm requirement. Only thing is that if each machine can have a critical speed, it can be 1 or 2. So vendor decide do this automatic calibration in such way ki when it is going to that critical zone, it will pass very fast state, it will go, and then it will go to MGS, minimum governor speed, and after minimum governor speed it will go to speed control, and then operator will take care as per the requirement. And then whenever system is running and as requirement is coming, he is going to speed increase the speed, and at particular mid speed between MGS and operating speed, he will take the extraction, and for the extraction come condensing turbine, and if it is normal turbine then it will be at MGS and it will go slowly to the operating speed as per the requirement. This chart which ramp up which I am discussing, if it is hot startup, it has having a different slope, and if it is having a startup after say 10 hours, it will be have a slightly different slope, and if it is after cold, then slope will be different. I will just show one chart how it looks like turbine startup. So this is the chart. So you can see this is the speed and this is the time, and for 3 conditions this is the critical speed it is shown, and 3 slopes are there. So that means if I am starting the plant, suppose the plant trip in running, then I will go slightly fast. That means our ramp up time will be less, and if I am going for after long shutdown, then it will be more time I will take. This why I am taking, because as the word itself tell you, cold and hot. Hot means no need to heat the turbine, and when it is cold, we have to ensure that each part of the casing, turbine, blades are at the same temperature. Means not at the same temperature, means properly heated, so that their expansion and contraction whatever are in the same range. If there is any deviation, then the problem is that one part has gone expanded, another not. So the clearances which was earlier met in mm, like 4 and if two parts are not going in the same expansion way, then this 4 will reduce, and then it will cause a problem. So this is all designed in such a way that it should go smooth. So startup and shutdown is very critical. Normal operation, when it is running, we don't have to bother much because automatic action take place. But this startup and shutdown, because manual intervention comes into picture, so we have to be very careful. A small mistake can damage the turbine. So this startup I told you like this. So for a small turbine there is a provision. When turbine is in standstill condition, we have to do the barring. Barring is basically, if it is shaft is heavy, then what is happening, if I will leave the shaft like this, it will have a sagging effect. To rotate, then what is happening, this part which small sagging is there, it will come up. So just we want to keep this rotating to avoid this sagging. That is one thing. And when machine is running, then initially to lift the shaft, because it is a very heavy, we have a jacking oil provision, so which will lift the shaft, and once it will go to certain minimum speed where oil will start develop the pushing pressure itself, then this jacking oil will go to automatically stop condition, but will be by condition for the set pressure at which we are setting it. And barring is also required when we are doing the heating of the turbine. So that what is happening, I am heating the turbine, so when I am rotating it, it is like you are heating a water and you are a stirrer. So this barring device is very important. Normally this is all automated barring device, but there is always a provision that if barring device fails, then you can do it manually also. Although it's a slightly typical thing, and we need maintenance help in that, how to engage the barring gear. And this engagement also is very critical, it should not get engaged in running condition, otherwise barring tooth will get damaged, because this barring device is only to rotate the shaft for very small rpms, maybe 10 rpms to 50 rpm, and normal speed is normally more than 6000 to 12,000, 13,000, depending upon the type of the turbine. So one has to be very careful. You should aware about all the logics, and like nowadays for the inlet XVs, we are ensuring that it should shut off when turbine is tripped. But nowadays new concept is that partial stop, that in running also we are closing this XVs partially. So depend upon the cell verification, it can be set at 6 month duration, it can be set at 1 year duration. So depending upon the criticality and the level of PSM or SIL, basically it's decided by the SIL and what level of safety we want to ensure. So this is required. So for all the critical machines, what we want, because once machine is running, XV is get full open and it remains full open for till any further tripping. So suppose we are having a very good operators and machine is healthy, and if it is running for 3 years, then what will happen after 3 years when we are going to trip the machine, it may that XV will not function. So because of that, if seeing the reliability options, what vendors are providing, they are providing hydraulic system in which this XVs are closing to 2% to 10%. That will not affect the running of the machine, because any valve which is open above 90%, it has of no use. 90% or 80% is the normal when we get the full flow from the valve, and this 10 or 20% is just for the safeguard. If any blockage or something is small, then it can take care. So what vendor is doing, it is 100%, and then with the hydraulic system it is coming to 90%, and there will not be any upset. So this is just to ensure that the system which XVs and solenoids are moving and functioning. So something when it is kept for long duration, it may jam. It is not necessary it will jam it, but to ensure the healthiness, this system, partial stroke system, is in use, and that is provided. So that's all for today. If you have any question, you can ask, you put a comment, and in my next session I will further add more on that. Thank you very much. Have a nice day.